Hello class of 2018. Today we're looking at using technology to find probabilities for normal distributions, and we're using technology and the inverse normal function to find x values when we're given probabilities, and we're going to use the symmetry properties to find probabilities. Now, your TI and Spire can find you normal cumulative probabilities for both x and z distributions. All you need to do is plug in your starting values and your ending values and work out the probability between them for you. Symmetry properties are a lot more interesting and useful. You'll find lots of questions to do with that. So our first one is probability that z is greater than a is the same as probability that z is less than negative a. So if I draw that in, it's easiest if I put the z values in here. That's a z, not a 2. That's a. So the probability that z is greater than positive a is the same as the probability that z is less than negative a. So there's my equal sign there. Here we have the probability that z is greater than a is the same as 1 minus the probability that z is less than a. So if I draw in a at the same spot here, sorry, I can't put it under here. The probability that z is greater than a is the same as 1 minus the probability that z is less than a. And for this one here, the probability that z is between positive a and negative a, that's an a, not a c, is equal to 1 minus 2 lots of that probability of probability of z being greater than a, that's this one here. Or you could actually say it's the same as 1 minus the other bit, so 2 times the probability that z is less than negative a. Right, so this inverse cumulative normal distribution will find you the x value given the probability. For example, I could ask you, what's the probability that, what's the a value that gives me a probability that x is less than a equals 0.7? So I know it's going to be bigger than the mean, and I'm going to ask you to find what this a value is. Note that your calculator will only give you answers that are less than a. If you want to find greater than in this bit over here, you need to use 1 minus probability that x is less than a in this case. So here's an easier example. You asked to find the probability that x is lying between 10 and 30, where the mean is 20 and the standard deviation is 5. If I do a little bit of a sketch first, that's x there, that's 20, and I know I'm going between 30 and 10. In this case, this one's actually quite straightforward. You can actually do this without a calculator because you know that the standard deviation is 5, and you know that these endpoints 30 and 10 are actually 2 lots of 5 away from 20. So you actually could just say the probability that x is between 10 and 30 is 0.95 without a calculator. If you wanted to use your calculator, then you just need to say what your minimum x value is, which is 10, your maximum x value is, which is 30, what your mean is, which is 20, and your standard deviation is 5, and it should give you the same answer. Now this one is a question asking you to use symmetry properties. So it's telling you that the probability that z is less than p is 0.3. So that's a clue to know that the p value is actually less than the mean of 0. So that is our given information, that's 0.30 there. A, the probability that z is greater than p is this number here. So it's 1 minus the probability that z is less than p, which is 1 minus 0.3, which is 0.70. You want to keep your significant figures. For part B, we have the original p-value here. There's 0.3 under there. The probability that z is greater than negative p is actually asking you for the negative p, which is over here, and greater than. Now, if you notice, this picture has a lot of symmetry to this picture. So it actually is the same value. It's the same as the probability that z is less than p, which is 0.30. Here we've got a classic set of problems where you're given some probabilities and you can do the first one without a calculator. So what we do is we actually draw in what we're given first. So if we have z is less than b is 0.8, we know that b is somewhere on the right hand side. So I can put a z value here and a b about there, and I know that this shaded area is 0.8. This next bit here is that the probability of z less than a is 0.25. That 0.25 tells me it's on the left hand arm of the distribution, so I can write in that a is somewhere over here, and I know that's 0.25 in there. That's a z, not a 2. Now, if I want to work this out for a, then what I need to do is work out the area between a and b. So I can draw this in over here, and I know b is somewhere over here, and a is somewhere over here. And I can actually say that the area between a and b is the same as the area to the left of b minus the area to the left of a. So that equals 0.8 minus 0.25, which is 0.55 for part A. For part B, I will require a new page. So I'll go to the next one. So from before, we have A over here, and that's 0.25 under there. And we have B over here, and that's 0.8 over here. So the probability of z less than a and z given z less than b requires a conditional probability equation. So if we do the conditional probability over here, the probability that z is less than a intersection with z less than b divided by the probability of z less than b. Now if I draw a little axis over here, we'll have a and b. Z less than a is over there, z less than b is over here, and so the answer is the overlapping section, which is z less than a. So hence we have probability of z less than a over probability of z less than b. And this one doesn't need any diagrams, you just plug in what you have. So it's 0.25 divided by 0.8, which is 0.3125. Now here you've got, you're given that you've got a normally distributed random variable x, you're told the mean and the standard deviation, and you're told the probability, but you're not told k. So this is a perfect case for the inverse normal distribution. It's always handy to draw a diagram, because then you can actually see what you're doing, and it will put an x in here. We have a mean of 8 and a standard deviation of 2, which we don't always have to label in. If we are told that the probability of x less than k is 0.6, then k has to be larger than the mean. So k is somewhere over here. And so this area in here is 0.6. Back in the old days you used tables, but we're going to use our CAS calculator. So my keystrokes are menu, distributions, menu probability, distributions, and then you do the inverse normal, and then it asks you for the area, so you state the area is 0.6. It's asking you for the mean, which we have to change to 8, and the standard deviation, which is 2, and the answer 0.6. The answer is that K is 8.50669, and that confirms what we have in start because K is bigger than 8. Perfect.